Okay, hello everyone. This is a video on Year 11 Maths Methods Binomial Expansion. So this question here, we're going to expand x plus y to the power of 5. Step 1, we know that we need Pascal's triangle up to n equals 5, so we start drawing that. Remember, we're adding this 1 plus 2 gives me 3, 2 plus 1 gives me 3. So you start with a 1, add the numbers directly above, and then finish with a 1. And I'm going up to n equals 5, which is this row here. Remembering we start at n equals 0, going all the way up. Okay, so we're going to use that in a moment. Let's leave that there for now. We know, because we've got x plus y to the power of 5, we are going to have one more term than 5, so we're going to have 6 terms. So let's write them out here. 1, 2, 3, 4, 5, 6 terms that we need to fill in, and they're all going to be added together. Okay, we can put in our coefficients. So we're using our coefficients here that we just found from row 5, and we've got 1, 5, 10, 10, 5, 1. And then we've got this first bit here, which is x, and this first bit here, which is y. So we start with x to the power of 5, and we work all our way down. X to the power of 5, x to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, x to the power of 0 here, which is just 1, so we don't even need to write it. And then we do the same thing with y. Again, we start at y to the power of 0, which is 1, so we don't need to write it. And then we have y to the power of 1, y to the power of 2, y to the power of 3, y to the power of 4, and y to the power of 5. So we've expanded. Our final step now is just to simplify this. We have x to the power of 5 plus 5x to the power of 4y plus 10x to the power of 3, y to the power of 2, plus 10x to the power of 2, y to the power of 3, plus 5x y to the power of 4, plus y to the power of 5. We do our little sense check. Every single term, the indices should add up to 5. We've got x to the power of 5, x to the 4, y to the 1, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 5 plus 0 is 5. Okay, our next example, we've got 3x minus 2y to the power of 4. So we need to do our Pascal's triangle up to row 4. So same thing again, I go 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Same thing, I'm adding the numbers directly above to give me the one below. Oh look, I've got to row 4. How do I know that? Because row 4, well, it starts with a 1 and then a 4. Row 3 starts with a 1 and then a 3. Same thing up. Row 2 starts with a 1 and then a 2. So I know I've got to row 4. I don't need to go any further for this question. Those are my coefficients. I've got to the power of 4, which means I'm going to have 4 plus 1 is 5 terms. So 1, 2, 3, 4, 5. I'm going to plus them all together. I'm going to fill in my coefficients. 1, 4, 6, 4, 1. And then, now this one is a little bit different to the last one. Because we've got 3x and negative 2y, I'm going to call this 3x A. And I'm going to call the negative 2y B. Okay. And I'm going to go, I've got a to the power of 4, starting with the highest power, working our way down. A to the 3, a to the 2, a to the 1, a to the 0 at the end, which we don't need to write. And then same thing again, working our way up. B to the 0, which we don't need to write here. B to the 1, B to the 2, B to the 3, B to the 4. Do our sense check. Do all the powers add to 4? Well, here they do, and here, and here, and here. So the reason I've done A and B is because I'm using, I'm expanding out A plus B to the power of n, in this case n is 4, and I'm going to now substitute in my values for A and B. So I've got 1 times a, which is 3x to the power of 4, plus 4a cubed b to the power of 1, plus 6a squared b squared, plus 4a b to the power of 3, running out of room here, plus 1 b to the power of 4. Same thing again. Now we just need to simplify. We've got 1 times 3 to the power of 4, which is 81x to the power of 4, plus 4 times 3 cubed. Well, 3 cubed is 27, and then 27 times 4 is 108. And 108 times negative 2 is going to give me 216, or negative 216. So I can change this plus sign here to a minus. Minus 216. That's my coefficient. I've got x cubed and 1y. Next one, I've got 6 times 3 squared times negative 2 squared. Well, again, 6 times 9 is 54. 54 times 4, I'm going to get positive 216 x squared y squared. So I just did 6 times 3 squared times negative 2 squared. Remember, negative 2 squared is positive 4. And that's how I ended up with 216. And then I've done my algebra, or I've got x squared and y squared. Next one, I've got 4 times 3 times, or negative 2 cubed, which is negative 8. So that's 4 times 3 is 12. 12 times negative 8 will give me negative 96. I've got 1x and I've got y cubed. Final one, I've got negative 2 to the power of 4, which is positive 16, and then y to the power of 4. Okay, we're noticing here, look, we've got a positive, a negative, a positive, a negative, a positive. See how they alternate like that? They start with a positive term and then they alternate positive, negative, positive, negative, positive. So that's a good little sense check. The reason that's happened is because we've got a negative here in between our two terms in the bracket. Okay, let's have a look at a surdy one. We've got raised to the power of 5, expanding this bracket to the power of 5. So step 1, Pascal's triangle up to row 5. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Noticing, I've got up to row 5. Remember, row 5 starts with 1, 5. So I can stop there. So I've got to the power of 5, my bracket, which means I'm going to have 5 plus 1 is 6 terms. So 1, 2, 3, 4, 5, 6. And we're going to plus them all together. Okay, we can fill in our coefficients. We've got 1, 5, 10, 10, 5, 1. I've just read those off of my row 5 from Pascal's triangle. And then same thing we did with the last one. We're going to say this big ugly guy is A, and this big ugly guy, including the negative, is B. Because we are going to expand A plus B to the power of 5 and then substitute in. So I've got 1, lots of A to the 5, and then we're just going to work our way down with our A's. A to the 4, A to the 3, A to the 2, A to the 1, A to the 0. Same thing going up, B to the 0, B to the 1, B to the 2, B to the 3, B to the 4, B to the 5. And now we can substitute in A and B. So we've got A to the power of 5 plus 5 times A to the power of 4 times B plus, I'm up to my third term now, 10 times A cubed and B squared, that's my fourth term, plus 10a squared b cubed, my goodness, plus 5a to the 1 and b to the 4 and 1 lot of b to the 5. So, what a big ugly mess. Let's clean this up. Okay, this first term, we have root 2 to the power of 5. Let's think about this for a moment. Root 2 to the power of 5. That's root 2 times root 2 times root 2 times root 2 times root 2. Okay, root 2 times root 2 is 2. And look, we have the same thing here. Root 2 times root 2, that's 2. So we're going to end up with 2 times 2 is 4 lots of root 2. Okay, this is big and ugly. Let's just take it one step at a time. So we've got root 2 to the power of 5. So that's 2 times 2, which is 4 times root 2. So we've got 4 root 2, and then x to the power of 3 times 5 is 15. Term 2, we've got 5 times root 2 to the power of 4. Well, root 2 squared is 2. So root 2 to the power of 4 is 2 times 2, which is 4. And then we have x to the power of 12 times negative root 3 y to the power of 4. Term 3, we have plus 10 times root 2 cubed, which is 2 root 2, x to the power of 9 times negative root 3 squared. Well, that's positive 3, and y to the power of 4 times 2 is 8, plus 10 times root 2 squared is 2, x to the power of 6 times negative root 3 cubed, which is negative 3 root 3, y to the power of 12, plus 5, we're up to here now this term, 5 times root 2x cubed times negative root 3 to the power of 4 is positive 3 times positive 3, so 9. And then y to the power of 4 times 4 is 16. And then final term, we have negative 3 to the power of 5, which again is 3 times 3 times negative root 3. So that's going to be negative 9 root 3. Y to the power of 4 times 5 is 20. So we've got all our terms. Let's just simplify one last time. Term 1, we've got 4 root 2 x to the power of 15. Term 2, 5 times 4 times negative root 3. Well, that's going to be negative 20 root 3 x to the power of 12, y to the power of 4. Plus, next one is 20 times 3 gives me 60 root 2 x to the power of 9, y to the power of 8, plus 10 times 2 is 20, times negative 3 is going to give me a negative 60 root 3 x to the power of 6, y to the power of 12, plus 5 times root 2 times 9. Well, 5 times 9 is 45, so that gives me 45 root 2 x to the power of 3, y to the power of 16. And then final term is simplified already, minus 9 root 3 y to the power of 20. Okay, so even for big ugly questions like this, our working out is still the same. Step 1, Pascal's triangle. Step 2, fill in our coefficients. Step 3, write our A's and B's in there. Step 4, substitute in for A and B, and then simplify until you can't simplify anymore. And again, because we've got a negative in between our two terms in our bracket here, we can sense check ourselves. We've got positive, negative, positive, negative, positive, negative, which is what we were expecting.